Greetings, I'm Dev the Developer.
And I'm Glitch.
Today we are talking about CSS color formats, not just what they are, but why each one exists and when you actually want it. We will start with a practical problem Glitch is going to run into, and the solution will pull every format into place. So, you are building an interface. You have picked a nice purple, and now I need you to create a hover state for the buttons, a lighter version of that purple. And when someone clicks, a darker version for the active state.
Oh, easy. I already have my base purple. Let me grab the color picker and find a lighter one. Okay, that looks lighter, but not quite. Maybe more this way.
How's it going?
It is fine. I think I found one. It looks right, I guess.
You're not sure whether your hover color is actually a lighter version of your base purple or just a purple that looks similar?
I mean, they look related. I picked from around the same area of the gradient.
Write down those two hex values, the base purple and the hover purple you just found.
Base is the hex value 7B68E. Hover is a 293F5, something like that.
Now tell me, looking at those two values, can you see the relationship between them?
I mean, no, they are just different strings of letters and numbers. I cannot see how one leads to the other.
That's the problem. Hex codes are precise, but they are opaque. They describe exactly what color you get, but they do not describe the color in a way a human can reason about. You cannot look at two hex values and say, this one's 20% lighter than that one. You have to compute it or guess.
Okay, so I am going to have three colors in my palette. A light version, a base, and a dark version, all the same purple. And right now, the only way I know to find them is to stare at a color picker until they look right.
Before we solve that, let's start from the beginning, because hex is not the only way to describe a color, and understanding why multiple formats exist is what makes the solution make sense. Start with the simplest one, named colors. CSS has about 140 built-in color names. Words like red, blue, green, white, black, hot pink, cornflower blue. You can use them anywhere CSS accepts a color value and the browser knows exactly what you mean.
I use those for quick tests all the time. Like when I just need to see where an element is on the page, I throw background color red on it and look.
That's exactly what they are best for. Readable, fast, no lookup required. But
there is only one blue, and it might not be the blue I want.
Right. Named colors or a shorthand for specific values. Red is the same as writing the hex value FF0000. Blue is FF for blue, so 0000FF. Nothing for red or green. Those are vivid, maxed out versions of their colors. Real designs almost never want that.
So named colors are good for color, red in a debugging situation, and not much else in a real project.
Some common shades are genuinely useful, black and white, transparent, but broadly yes. Named colors are a convenience, not a precise tool. Let's build the demo so we have something to work with.
I want to call mine an interface dashboard for monitoring network infrastructure.
Sure.
Okay, and the CSS file is empty for now. Let me put some named colors on it just to prove they work. That works. Dark background, white text, no hex involved. But this black and white are pure black and pure white, and that is kind of harsh. Real designs usually want something a little off.
Which is where hex comes in, the format you have already been using since the beginning. Let's talk about what it actually means. A CSS hex color starts with a hash sign, then 6 hexadecimal digits. Hexadecimal is base 16, meaning each digit can be 0 through 9 or A through F. A through F represents the values 10 through 15. So a hex digit holds 16 possible values, 0 through 15.
Wait, so why base 16? Why not just use normal numbers?
because two hexadecimal digits can represent every value from 0 to 255, which is the range of a single color channel. 0 is, well, 0, 0. 255 is FF. It fits exactly into 2 characters. In decimal, 255 takes 3 characters. Hex is more compact for this specific range.
Oh, so it is a storage efficiency thing. 2 digits per channel fits the range perfectly.
The 6 hex digits in a color are 3 pairs. The first pair is the red channel, second pair, the green channel, and the third pair is the blue channel. Each pair is its own number from 00 to FF.
So the hex value 7B68E is 7 billion for red, 68 for green, and EE for blue, all in hexadecimal.
Not billion, B, but yes. Can you tell me what those are in decimal?
Let me work that out. 7 billion, 7 times 16 is 112, plus 11 is 123. So red is 123, 68. 6 times 16 is 96, plus 8 is 104. Green is 104. EE, 14 times 16 is 224, plus 14 is 238. Blue is 238.
So that purple is red 123, green 104, and blue 238. A lot of blue, less red, and even less green.
Oh, that actually makes sense as a purple. More blue than red, barely any green. I have been writing hex codes this whole course and I never decoded one before.
Most people don't. They use a color picker, copy the hex, and move on. Nothing wrong with that, but knowing what the digits means helps later, especially when we get to other formats.
Let me replace these named colors with real hex values. That is much better. A deep dark blue-black for the background, soft off-white for the text, nothing harsh.
Good. Now, there's a shorthand form. When both digits in each pair are identical, you can collapse each pair into a single digit. 6 digits become 3. The browser expands each digit by repeating it.
So the hex value 111,111 could be written as 3 ones.
Exactly. Each 1 expands to 1. 11 in hexadecimal is 17 in decimal. So 111 is the same as 111, which is red 17, green 17, and blue 17. A very dark, near black gray.
In the hex value, FFFFFF shortens to 3 Fs. FFF, each F expands back to FF, that's white.
Right, but if any pair has mismatched digits, the shorthand does not apply. The hex value 7B68EE cannot be shortened because none of the pairs match.
Makes sense. 7 billion cannot become 1 digit because 7 and B are different. You can only drop the second digit if it is the same as the first.
The shorthand is purely cosmetic. Use it when it reads cleaner. The browser treats both forms identically.
Okay, so back to my actual problem. I want a base purple, a lighter version for hover states, and a darker version for active states. I have the base. I need to find the other 2 in hex, and I still have no idea how to do that without guessing in a color picker.
Hold on to that problem. We're going to build up to the answer. The next format is the RGB function.
Wait, so is this the same information as hex, just written differently?
Mostly. The RGB function takes 3 values, red, green, and blue, each one from 0 to 255 in decimal, not hex.
So that purple, which decoded to red 123, green 104, blue 238, would just be the RGB function with 123, 104, 238.
Write it.
Okay, so the heading and the subheadings are both purple, but the heading is using hex and the subheadings are using the RGB function. And they look the same color. Are they exactly the same?
Exactly the same. The hex value 7B68EE and RGB 123, 104, 238 are the same instruction to the browser. Different notation, same result.
So when would you use the RGB function over hex? They give you the same colors.
Readability sometimes. Hex is compact but opaque. When you see RGB 123, 104, 238, you immediately know the color values without converting anything. Some developers also find it easier to manipulate. If you want more blue, you add it to the third number. You don't have to think about it in base 16.
Honestly, if I already know my hex value, I would probably just keep using hex. The RGB function looks more typing for the same result.
Fair assessment. The RGB function starts to earn its keep when you combine it with the fourth channel.
Wait, a fourth channel?
The alpha channel, opacity. That's what the RGBA function adds. Same three color values plus a fourth number between 0 and 1. 0 is fully transparent, 1 is fully opaque. Anything in between gives you partial transparency.
So the RGBA function with 123, 104, 238, and 0.5 as the fourth value would be that same purple at half opacity.
Half transparent, yes. The browser blends it with whatever is behind it.
That is actually useful for overlays, like if I want a dark tinted layer over a background image.
That's its primary use case. Add a semi-transparent dark overlay on top of a background image to make text readable without completely hiding the image. Let me have you build that.
I need to add a div to the HTML first for the overlay. Let me add it to the header. Now the CSS, a semi-transparent dark background on the overlay div. Okay, so the overlay div has a dark tint. If the header had a background image, you would see it through the tint. Right now it just looks like a slightly different dark, but I can see how it would work over an image.
Now try something. Set the alpha to 0.
It disappeared, the dark tint is gone, the div is invisible now.
Is it gone?
Well, the background color is gone, but the padding is still there. The element is still in the layout, pushing things around. It is just invisible.
An element with a transparent background color is not absent. It is present, occupying space in the document, receiving events, participating in the layout. It has simply nothing visible drawn for its background.
So it is invisible but still there, fully embedded in the document structure. No visible footprint, still present in every meaningful technical sense, accepting inputs, responding to interactions. A transparent layer the viewer does not know is there. I mean, that is just how transparent overlays work for UI design, which is the context we are discussing.
Set the alpha back to something visible, then tell me what you notice about the RGBA function compared to the RGB function.
The only difference is the fourth number. Everything else is exactly the same format.
Which is why some developers use RGBA for everything, even colors they do not want to be transparent. They write the alpha as 1, which is fully opaque. That way, all their color values look consistent in the style sheet.
I could see that. RGBA 123, 104, 238, 1, and RGBA 123, 104, 238, 0.5 look like a matched set. The relationship between them is immediately obvious.
Now, back to the palette problem. You have a purple. You need a lighter version and a darker version. You still cannot solve that in hex or RGB without either using a color picker or doing math. Why?
Because neither format thinks in terms of lighter or darker. Hex and the RGB function think in channels. How much red, how much green, how much blue. Making something lighter means increasing all three channels in the right ratio, and I do not immediately know what that ratio is just by looking at the numbers.
Think about how a painter talks about color versus how a printer talks about color.
A painter would say something like this blue, but lighter. They are reasoning about the color as a whole, its identity, its brightness. A printer would say 5% cyan, 12% magenta. They are specifying exact channel amounts.
Hex and the RGB function are the printer, precise channel values. The browser understands them perfectly, But that's not how humans think about color intuitively. The HSL function is the painter.
Wait, so HSL is a completely different model for thinking about color, not channels.
3 components: hue, saturation, and lightness. Hue is an angle on the color wheel from 0 to 360. 0 degrees is red, 60 degrees is yellow, 120 is green, 180 is cyan, and 240 is blue. 300 is magenta. 360 brings you all the way back around to red.
So a purple would be somewhere between 240 and 300.
Try it. What angle do you think that purple sits at?
Blue is 240, magenta is 300. Purple is somewhere between those, maybe 250, 255 degrees.
The hue for a blue-purple sits right around 250. We'll nail it down in a moment. Saturation is next. A percentage 0 to 100. 0% saturation is gray, no color at all. 100% is fully vivid.
So saturation is how colorful it is. A 50% saturation purple is a muted purple with gray mixed in. A 100% saturation purple is as vivid as it gets.
Right, and lightness. Also a percentage. 0% is black, regardless of hue or saturation. 100% is white. 50% is the pure hue at full intensity.
So to make a lighter version of a color, I just raise the lightness percentage. And to make it darker, I lower it. The hue stays the same. The color identity stays the same, just the brightness changes.
That's what the HSL function gives you that Hex cannot, a direct handle on a human concept.
Okay, I need to figure out my purple in HSL. The hex value 7B68E decoded to red 123, green 104, blue 238. Let me look up the conversion. The hue is approximately 250 degrees, saturation around 79%, lightness around 67%.
Close enough to start. Write it and compare visually.
Okay, they look very close, maybe not pixel perfect, but close enough to work with. Now I can actually build my palette.
Before you do that, what does 79% saturation feel like to you?
It is a pretty vivid purple, not completely maxed out, but you can tell it is definitively purple, not a washed out blue-gray thing.
Try dropping the saturation to 40%. Keep the hue and lightness the same.
Oh, that is a much softer, more muted purple, almost lavender gray, same hue, way less vivid.
Put the saturation back to 79. Now, I want you to build the palette you actually needed, based on color, light version for hover states, dark version for active states. Same hue, same saturation, just vary the lightness.
Okay, base is at 67% lightness. I want the light version to be noticeably brighter, maybe 80%. The dark version should be distinctly darker, maybe 45%. I want to set up some classes for this so I can see them side by side. That's actually really satisfying. 3 purples, clearly related, clearly distinct. I changed one number to go between them.
And more importantly, can you see the relationship between them by reading the code?
Yes, the hue is 250 across all 3. The saturation is 79% across all 3. The only difference is 80, 67, and 45 in the lightness slot. Anyone reading this style sheet knows immediately that these are the same purple at different brightnesses.
Compare that to 3 hex values. The hex value 7B68EE, the hex value A08FE8, the hex value 4D, 3D, B5. Those are roughly the same purples in hex. Does reading them tell you anything about the relationship?
Nothing, they are just 3 unrelated strings. I could not tell from looking at them that they are the same purple at different lightnesses.
That's the practical advantage of the HSL function. Not that it's more precise than hex, not that it produces colors hex cannot produce. It just makes the relationship between colors visible in the code itself.
Wait, so can I build an entire color palette from one hue, like a full range from very light to very dark, all with the same identity?
That is exactly how component design systems are built. A base hue, a fixed saturation, and a range of lightness values from near white to near black. Usually 10 or so steps.
So if I wanted a full scale. Oh, that is a complete purple scale. Every step is clearly in the same family. I can read this style sheet and immediately understand the whole palette.
And if you decide that purple is slightly too blue and you want it more violet, how many numbers do you change?
Just the hue, change 250 to 265 in every rule and the whole palette shifts together. Or, wait, I could just change it in one place if I used a CSS variable. But we are not there yet.
That's very good instinct. We'll get there.
So named colors are for readability and quick tests. Hex is compact and precise but opaque. The RGB function is the same as hex but in decimal, more readable channel values. The RGBA function adds transparency. And the HSL function is for building palettes and reasoning about color like a designer instead of like a computer.
As a clean summary, there's one more thing to mention about the HSL function. It has a transparency version also, the way RGB does.
HSLA.
Same idea. Fourth value from 0 to 1 for the alpha channel. A semi-transparent purple overlay would be HSLA with your hue, saturation, lightness, and then the opacity value.
So I could do a semi-transparent version of any step in my palette scale without any additional color picking. Just take the HSL value and add an alpha.
Right. Say you want a subtle purple tint as a hover highlight and not as a solid color. Take the base purple, set the alpha to something like 0.15, and you get a ghost of the color.
Oh wait, we just added a pseudo class there. We have used those before, so it should be fine.
That's within scope, yes.
Okay, so HSLA is to HSL what RGBA is to RGB, just adds the fourth channel.
Modern CSS actually lets you skip the separate RGBA and HSLA functions entirely. The RGB function and the HSL function both accept an optional fourth value for alpha now. The older 4-letter versions still work, but the 3-letter versions handle it too. You'll see both in code bases.
Wait, so passing a fourth alpha value directly to the RGB function is valid now, without the A?
It is. The syntax evolved. In practice, you'll encounter all 4 function names in existing code. Any of them will work in a modern browser.
That is good to know. I do not want to see RGBA in someone's code and think it is a different thing from RGB.
They're the same thing. The older function just made the intent explicit with the extra letter. Use whichever reads better to you.
Okay, let me put the palette back together more cleanly. I want the interface to actually look like something. That's actually coming together. I can see how the whole color story works. The dark background is the low lightness version, the headings are the mid lightness version, the accent borders are a slightly different lightness. And the footer uses a desaturated version of the same hue for a quieter presence.
Notice what you did to that footer. Same hue, lower saturation. That is a different dimension of adjustment than lightness. You're pulling 2 handles independently.
Right, saturation controls how colorful it is, lightness controls how bright. I can mix them independently. In Hex, I would have no idea where to even start. I would be sampling from a color picker and hoping it looked related.
One format in every color value. The HSL function for everything, that is a legitimate way to work. Some design systems go all in for this exact reason.
Wait, so do most developers use HSL for everything, or is Hex still the main thing?
Hex is still the most common format in existing code because it was the default for a long time. But the HSL function has been gaining ground, especially with CSS variables. When you can write a custom property as a hue, a saturation, and a lightness separately, and then compose them in a color value, you get even more flexibility. But there's a conversation for when we have covered custom properties.
That is a very tantalizing door to leave slightly open.
You can see it from here. Let's close this one first.
Okay, so to actually answer the question from the beginning, Dev asked me for a lighter purple and a darker purple. In Hex, I was guessing. In HSL, I just adjust the lightness. The answer to the problem was using a color format that thinks in human terms.
And the reason there are multiple formats is that they serve different situations. Hex is everywhere, and you will read it, write it, copy it from design tools. RGB makes color values explicit. RGBA and HSLA add transparency to their respective formats. And HSL gives you the palette building superpower, a direct handle on hue, saturation, and lightness independently.
And they can all appear in the same style sheet. I can use Hex for background colors. I copied from a design mockup in HSL for anything I am building from scratch or adjusting in code.
All of them are valid anywhere CSS expects a color. Mix freely based on what makes the code clearest. Here's something worth trying. Pick the purple you've been working with today, express it in every format, a name color. If there is a close enough approximation, the hex value, the RGB function, RGBA function at full opacity, and the HSL function. Put all 5 versions in your style sheet targeting different elements. Look at them in the browser and verify they all render the same color. Then pick a different color and build out a light, base, and dark version using HSL. Don't just watch it, do it.